This is Harry with Mine Operator, and today we're going to do a little copper experiment. We ran across a copper vein inside of our mine when we were underhand stoping, and I crushed about 3 pounds of it. And since it's Chrysocolla and there's some Chalcopyrite in there, we're going to perform a sulphuric acid leach using about 5% sulphuric acid and see what we get out of this, see how good the ore is. I'll prepare about a 1 pound sample so I can get a good idea about what a ton of this material would run us and how much copper would be in it. We'll measure out 1 pound. This material's been crushed to -1/8 inch, so it should give enough surface area for the sulphuric acid to get inside of the rock. Now the vein itself is only a few inches thick, and it's not really worth the effort to mine it, but since we're already there for gold, it doesn't take very long to throw a few pieces of this aside when you're mining and sampling, and then we can do a small little test. Now what I'll do is I'll add 1,000 milliliters, or basically a liter, of water and 5% sulphuric acid. And I went over a little bit. And that should pretty much remove all the copper from the material. And the recovery method, I haven't decided on yet. I was contemplating doing electrowinning, but that'll take some monitoring. And if I just use iron to replace the copper, that'll be something I don't have to monitor until the reaction's complete. So we'll call that good with 1 pound, and we'll measure up our leach solution. So I've got a 1 liter beaker, and I'll measure out about 900 milliliters of water, and I'm just using tap water because I don't care about the minerals that are in the water in this case. It's not going to be an issue for me. So I'll measure out 50 milliliters concentrated sulphuric acid. Now the stuff from the store is not clear, so this stuff's got this red color. So when I first start the reaction, it'll look pink. And this is adding sulphuric acid to water will create heat, but since this is room temperature, it's only 5%. I'll be all right adding 50 milliliters to about 950. Now that my solution's mixed up, we can get going. So we'll top this thing off at 1,000. Now liquid's gone turbid because there was a lot of fine particles in there from when I crushed it, but that'll settle out. And the time is 5 o'clock Saturday. And while we're waiting for it to react, I'll show you what the actual ore looks like. And while we're waiting, I'll take you and show you where we found it. And I got Mr. Hollywood here with me, and I told you I was going to take you down and show you where I got that copper. Say hi, Mr. Hollywood.
Hola.
Hola. So this is the full width of the vein. So this would be the foot wall. This is the hanging wall. And our gold is running in the foot wall portion. We have our copper vein, and this is where I took the sample from and ran. So now you can see where it's coming from. Now to mine this wouldn't really be economical because this would have to widen out for us to take this little sliver of the vein and then this little sliver of the gold. We'd have to remove all this other material to get to these veins to high grade them. So what we'll have to do is chase these stringers in the vein down and see if it widens out down below. But it does get wider the deeper we go, so there's hope. But this is the stuff. What do you think, Mr. Hollywood?
Good stuff.
Good stuff.
More is better.
More is better. It's been about 30 minutes, so the time is now 5:30, and you can see the reaction has already begun, and the leach is starting to work, and the acid is starting to penetrate, and the liquid is starting to turn blue. And in a few hours from now, it'll be a dark, bright blue, and that means that copper is entering into solution. There'll be other minerals in there as well, things like antimony, lead. There's not too much tin or nickel or cobalt in our ore, but there is iron as well. But this will primarily target the copper. All right, it's 8 a.m. the next day, so a little over 12 hours. And it's a nice crystal blue color. Well, it's been a little over 24 hours, so it's now 7 p.m. the next day, so 26 hours. And this is where we're at. Been having to stir, and the reason is you get these oxygen bubbles forming, and it's preventing the leach from getting to the fine material. So I think maybe next time I might go a little coarser. If you have any ideas on that at all, if I should crush this to a coarser material as opposed to a -1/8 inch, love to hear your comments. Well, it's been 2 days, so we're gonna discontinue the reaction and filter off the solution, the pregnant solution from the ore. I'm using 94mm filter paper. As well as the coffee filter. With sulphuric acid, the paper won't last long, so once I get it filtered, I'll remove the paper and set it aside to dry. I'm going to pan the material in here to see if there's any free mill gold. Alright, here we go. So first I'll decant this. No more blue. Well, I lied. There's a couple of little blue specks in there, but we got it all for the most part. I'm just about done filtering. There'll be more than 1,000 milliliters in here due to the rinse water. And I plan on rinsing this material one more time. Alright, we'll let gravity do the rest. So here's our solution, and due to time considerations I've decided to drop the copper out using iron as opposed to electrowinning. So if you would like to see me do this again with electrowinning, then leave a comment and I'll be happy to redo the experiment. I've already kept the heat up to about 40 degrees Celsius. That usually helps the reaction. I have no idea what the right temperature is, but this has always been a temperature that's helped me. I'm going to add a little stir bar in here. Doesn't have to go all that fast. It just kind of helps when any of the iron or iron oxides that comes off this piece of steel, it helps them kind of keep them suspended in solution so I have less contamination. So this is just a piece of scrap steel that I have. Any steel will work, preferably one that isn't high carbon steel or an alloyed steel. The purer the better, but anything works. And using the series of reactivity of metals, over here, this is copper 2 sulphate. So I don't know if you can read my little list over here. There's the copper. And we're going to use iron. So everything between the iron and copper should be dropped out from the iron. However, most of these minerals are not in solution, and if they are, they'll be in trace amounts, and they are not recoverable unless we do another refining with the copper. We'll do copper refining step. If I have enough copper, I'll do it, but for this experiment, I'll just drop this with iron. The reason why I'm using iron is because it's the cheapest of all the metals, aside from lead, and I don't want to use lead, and iron seems to work the best for this experiment. I do have a lot of zinc, but I have no use for zinc sulfate, so Iron sulfate is cheap and it's easy to dispose of. So I use a magnet to attach this to the side so you can see the copper drop. And this is a slow reaction, so once it begins, I'll catch you up. Get a little more light here. I don't know if you can see it, but we've already begun the reaction, and it's probably hard to tell, but the copper is already starting to show up on the steel. So I began this at about almost 7:45. So if you haven't noticed, my clock runs backwards. It's a joke I have from somebody that gave this to me a while ago. So everybody loves this clock, but it runs backwards. So if you're wondering about that, that's what's going on. It's 7:45, so this should take about a day. And when the reaction is complete, I'll start to get this sludge, this iron sludge that starts to build up, and I usually knock it off when the copper starts to turn black, and that's pretty much when the reaction is complete. So well, it's just after 5:30 the next day, and you can see the copper is still being dropped out of solution, and iron is replacing it, and the color has changed to a lighter color. Before it was that dark blue, and now it's this very, very light tint. So now we pretty much made iron 2 sulfate. We'll let this keep going. Well, the reaction is still going. The liquid is turned almost clear, but there's a slight discoloration from the iron. So I'm going to keep letting this go. Either there's that much copper in the solution, or I did not have enough material for the 5% sulfuric acid to dissolve all the copper. So there's a good chance I have just redissolved the copper in the solution as it precipitated out. So that's a possibility. So I think the next time I will go with a larger sample and keep the same size. So maybe go with 2 pounds instead of 1, just to make sure. But usually I'm done with dropping copper out at this point. So this is the largest sample I've done. So yeah, I'm still learning. Okay, it's been 2 days with the iron in solution, and the copper is starting to turn dark. So that tells me the copper is pretty much all out of solution, and now it is the other base metals between copper and iron that's left. So I'm going to discontinue the reaction and filter off the copper and melt it down and get a weight. That's it right there. I'll fish that stir bar out of there and we'll get to melting. Get out of there. All right, let's weigh this thing. So 14.94 grams. And we did that from a 1 pound sample. So what would that be? So 14.9 grams, we'll call that, we'll convert that to pounds. I already did the math, and it's 0.0329 pounds. And we did a 1 pound sample, so if I multiply that by 2,000, that gives us 65.8 pounds. So that's what that particular spot is running. So if I do the math on that, 65 divided by 2,000 times 100. So that means that particular part of the vein that I ran, a 1 pound sample, is 3.25% copper. But I don't know what the mineral content of this is now. So I'm going to find out here shortly and scan this with the XRF and find out if I get any base metals that carried over due to this lighter gold or good looking color, I'm suspecting that a base metal like tin or lead or nickel or something came through, but I'm not going to be sure till I test. So let me fire up the XRF and we'll get on it. Alright, I got my XRF calibrated and we're going to go with precious metals mode. See if I can get you in here close enough for this to work. Let's balance this one, huh? So this is going into precious metal mode. There's copper. We did all right. A little bit of gold made it in there too. That's normal for copper refining with sulphuric acid. Gold always carries through if there's gold in the ore. So we got a tiny bit of gold in there. Right, so 3/9 fine copper with trace gold. I wouldn't go off of that 0.07% as the gold by weight in there. Let me scan the top, see what we get. See if we can repeat that. I see the iron slag on the top. There you go, there's gold. So there is gold in our copper ore, and I panned this afternoon the tailings from the leach, and I did not get any visible gold. And that doesn't mean that there's not free mill gold in there, I just have it crushed to -1/8 inch. So there you go, copper and gold. So this will conclude our little experiment here from a 1 pound sample, and we're able to take the rock from the vein and we're able to turn it into copper, physical copper. So I think that's pretty neat. I know it's kind of nerdy. We normally just break rock and crush it and make gold, but there's gold in here too. And when there's enough of copper like this for a large scale deposit, commercial deposit, where you have billions and billions of tons of this stuff, it makes it worth it to get the gold out. But for us, at 3.5%, and I don't even know what I'm going to get paid for this from a refiner, it's not worth it, but it's a pretty rock. Thanks for watching.